Let's do some more practice using some of the homework problems. We'll start with question number 3. Suppose that the world's current oil reserves is R equals 2060 billion barrels. If on average the total reserves are decreasing by 17 billions of barrels oil every year, answer the following. Part A. Give a linear equation for the total remaining oil reserves R in billions of barrels in terms of T, the number of years since now. Use a correct variable and preview before you submit. So, R is linear. So if we know R is linear, then what is it going to look like? R is just going to equal some starting value plus the slope and times our input value, and our input value is T, not X here. So let's look at the problem. What is our starting value? Well, we're starting right now. It says we have 2,060 billions of barrels, and we're in billions of barrels. So our starting value, it's just going to be 2060. How is this changing every year? Well, it's decreasing by 17 billion barrels every year. So that gives us our slope. It's decreasing, so our slope is going to be negative by 17 billions of barrels every year. There we go. We got our equation. So when it says use the correct variable, that just wants you to know that if you wrote 2060 minus 17 times x, it would give you the wrong thing. Okay. Our input variable is time here. And now it's much happier. What are the oil reserves going to be 8 years from now? That's going to be, what is R when we're 8 years from now? That's when T is 8. We can just use the formula. R is 2060 minus 17 times 8. Plug that into a calculator and you got your answer. Oh, I don't have Desmos anymore. 2060 minus 17 times 8, 1924. Again, this is billions of barrels. So 1924, and it already tells you that it's already taking your answer in billions of barrels. If no other oil is deposited into the reserves will be completely depleted in how many years? Round to 2 decimal places. So when are things depleted? That just means, when is R equal to 0? Find T. 0 is equal to B, which is 2060, minus 17 times T, which we want to find. Add 17T to both sides. We get 17T equals 2060. And we can just divide both sides by 17. T is going to be 2060 over 17, which is 121.18 is how we round. Remember, they wanted us to round here to 2 decimal places. There you go. It's funny, I was just thinking, man, I'm really tired. These videos have been really long, and then I was realizing, well, my students are probably also really tired this section. It's had really long videos. Oh gosh. Let's do number 6. Trying to find the balance. Don't want too many long videos, but also want to give you enough support for if you need them. Question 6. You decide to start selling bottles of water at the local Swap Mart. I don't really know what that is. The cost for you for each bottle of water is $2.59. Goodness gracious. Yeah, you need a better supplier. And you have to pay a weekly fixed cost, a fee of $140 for that booth. And your plan currently is to sell each bottle of water for $3.71. Very questionable business choices, I have to say, not being a business person myself. But you have a booth and you say $3.71, please. People are going to just look at you and be like, why did you choose $3.71? So let's write a cost function, C of n. Function notation. C is the output, n is the input. To express your total costs for a week if you want to sell n bottles of water. So C is a function of n, and that's going to be fixed costs plus your variable costs. Well, what are the fixed costs on a week? Well, it says you have a weekly fee of $140 for this booth. Every week, you're going to have to pay that 140 bucks. Variable costs are how does your cost change depending on your production? Well, our cost for each bottle that we sell, N, is $2.59. $2.59 for every one. This is what our cost function looks like. Cost is a function of N. It's always going to be a fixed cost of 140. And we also have to pay $2.59 for each water bottle that we sell. Let's input that and see if it likes it. 140 plus 259N. And again, use X here, not going to like it. Make sure you use the right variable. All right, let's do the same thing now for revenue. Revenue, well, we don't have any fixed revenue here. No guaranteed revenue, sorry. But we are selling each bottle of water for $3.71. So we make that much revenue for every input. We usually don't write the dot there. Not wrong. Usually we write it like this. 371N. And now it wants us to find the profit. Well, profit as a function of N is going to be the revenue as a function of N minus the costs as a function of N. I usually don't write this in function notation, but this is what it would look like in function notation. So our profit as a function is the revenue, which is 371N, minus the costs, which is 140 plus 259N. And again, this is not correct as I've written it, because we need to subtract the whole cost. So we'll subtract it in parentheses and simplify. The negative distributes. Our profit as a function of N is 371N minus 259N. How much are we profiting on a given water bottle? $1.12 minus $140. That's our profit function. 112N minus 140. How many items must you sell to break even? You could find when revenue is equal to cost. That's break even point. Or since we already have the profit function, it's going to be easier to find when profit's 0. When is our profit function equal to 0? Again, that wants us to find N. So the profit function is $1.12 for every water bottle minus 140. When is that equal to 0? Well, let's solve. Add 140 to each side. That'll give us that 140 equals $1.12 for every water bottle. Divide by 112. And we'll get that N, 140 over 112. 125 water bottles exactly in a week if we want to break even. If we want to spend a whole week doing something and not lose money. So hopefully we're selling a lot more than 125. Okay, because according to this cost function, we have no value on our time. We could make our cost function more accurate by saying, well, how do I value my time? Maybe I value my time as 10 cents every hour. Or maybe you value your time a little higher. You could add that as a fixed cost. Like if you're at this Swap Mart 20 hours a week, then you could add to your fixed costs 20 times whatever you value your time at. That could be a way to make this problem a little bit more interesting. Uh-oh. What did I do wrong? I said that we're profiting $112 for every water bottle. Woo, that'd be a good racket. All right, that should be good. Man, I don't know how I'm selling these water bottles for so much, but that would be some nice profit. Or some really big water bottles. Let's do the last one. Then it's lunchtime. I'm still hungry from thinking about those donuts in a previous video. We got a baseball team. They're playing in a stadium that holds 60,000 spectators. When the ticket price is at $8, that seems cheap. The average attendance is about 24,000. When the price dropped all the way to $4, attendance rose to 30,000. Find a demand function. Usually we did QD. Here we're going to talk about our demand function, D of Q, where Q is the quantity or number of spectators. Okay. So let's look at the relationship. Again, this one's a little weird because our demand function now is telling us our price. Q is the spectators, and our output is going to be price in this case, which is a little flipped from what we have. And we're using D for demand of price. It's a little bit of a weird problem that's not really consistent with our notation, which is why I'm doing it now, because again, there are a lot of different ways of formulating this. And the book has a certain notation that we've been using in the notes to kind of streamline things for you. But if you take an economics class, they're going to use very different variables. And a lot of times they will solve and write things in this format. So it's good that you're seeing it. But I try to be consistent most of the time to make things a little bit more straightforward. Okay, let's be very careful with this question. So D of Q is going to be the price at attendance Q. I don't know how to spell attendance. Is it E at the end? No, it's an A. I got it right. Great. And we're going to assume D of Q is linear. So D of Q is going to be B plus M times Q. And if you want, you can just write this as P. All right, so we need to find the slope. We need to find the starting value. We've got a bunch of information. 60,000 spectators, that's going to be useful for domain and range if it ever comes to that. But the important thing is that price of $8, attendance is 24,000. Be very careful. Price of $8, attendance is 24,000. That is not this. Why? Because in this formulation, Q is the attendance, Q is our input. So watch out. How is the function formulated? The attendance is the input, and the price is the output according to here. And that can be valid. Let's say you own this stadium, or you're managing it, and you're saying, okay, if I want this many people to show up, what price do I have to charge? All right. That's how we're going to do it this way. And then the other piece of information was a price of $4 was an attendance of 30,000. And the problem specifies on average that attendance. So maybe they took a couple data points, right? They did a few different weeks. Maybe they tried to make it really consistent and try to get good, accurate data. So we can use this to find the slope. Slope is change in output, second minus first, over change in input, second minus first. You'll get -4 on the top. You'll get 6,000 on the bottom. You simplify that, it's -1 over 1,500. Which means, that's kind of weird. If more people, our input's attendance, if more people come, then how does our price have to change? And if we want one more person to come, our price goes down by 1 over 1,500. That's kind of weird to think about it. Another way to think about it is if we want 1,500 more people to come, our price has to go down by $1. So P, or you can use D of Q still, is B minus 1 over 1500 times Q. And if you're nervous about the slope, plug in some attendance numbers and see if this checks out. We'll do this actually after. That'll be easier to do once we find the B value. We could use either one of these points to find the B value. I'm going to choose the one with 30,000. I don't know. It doesn't matter. A price of 4 will give us a B value. Negative 1 over 1500 times our Q was 30,000. I chose this one because I can do this one in my head. The 4 is equal to B minus, that is 20. Our B value is 24. Okay. So our price is 24 minus 1 over 1500 times Q, which means that if we want nobody to show up, if Q is 0, we want nobody to show up, we'll charge 24 bucks for a ticket. And again, that's not true. It's not true that charging $24 a ticket will have 0 people attend. This is a linear model. It's not a full-on accurate description of reality. It's just a model. And models usually, especially linear models, models break down in accuracy near the edges of their domains. All right. And the edges of the domain here, if we did ask the domain, right, it'd be 0 to 60,000. Because if we're talking about attendance, those are the attendance numbers that make sense. The stadium can hold 60,000. So this is our function. I'm writing P. This is a little easier, but D of Q is the same thing. And that's all we need, the attendance function. Okay. 24 minus 1500 Q. Sorry, 1 over 1500 Q. And again, if you wanted to, you could also check your answers. D of Q equaling 24 minus 1 over 1500 times Q. You could say, well, what is our demand? Like, what price do we have to be if we want 24,000 people to show up? It says $8. That's what we thought. What about if we want 30,000 to show up? $4. That's what we thought. So if you're on your last attempt on this, which probably won't happen, but that's one way that you could check. And there we go. We got it. Let me know if you have questions on any of these other homework problems, and you can also post on the discussion thread or whatever as well. Bye-bye. Good luck.